Our next problem says that f of x is equal to negative 1/2 times x squared plus 13 over 2. It has a minimum value of 2a and a maximum value of 2b on the interval from a to b inclusive. Find this interval. First, we know that our parabola is downward opening because the coefficient in front of the x squared term is negative. And we can also find where its line of symmetry lies. This is when x is equal to negative b over 2a when we're referencing this standard form of a quadratic. In this case, b, which is the coefficient of the x term, is 0. So x is equal to 0 for this line. Our first case is when a and b, both ends of the interval, are less than or equal to 0. This means that our interval would be from here and to the left. In this case, the maximum value would happen where we have f of b, and the minimum value would happen where we have f of a, because this portion of the function is always increasing. And our next case is when 0 is included in the interval from a to b. It means a is somewhere here on the left side of x equals to 0, and b is somewhere on the right side of x is equal to 0. But this case gets slightly more complicated, so we'll have to split into two smaller cases. First of all, we know that no matter where a and b is relative to x equals to 0, the maximum value would always be the value of the vertex, which is equal to f of 0, which is equal to 13 over 2, which is equal to 2b. It's only on the minimum value that we have to split into further cases to talk about. The first case, we'll call it case A, is when a is less than 13 over 4. So where did we get this? Well, in case 2, we know that 13 over 2 is equal to 2b, which means that b, no matter what, is 13 over 4. And if x is equal to 0 is right down the middle of this interval, we would get something like this is x is equal to 13 over 4, and this is x is equal to negative 13 over 4. So if a, which is the left end of the interval, is less than negative 13 over 4, it means that our intervals are like this. The portion of f of x we're talking about here right now is like this. So the minimum value occurs when we have f of a, and it would be represented as 2a. And now what if we had a is greater than negative 13 over 4 and less than 0? Now in this case, I'm going to write it in blue. It means a is somewhere here. It's between negative 13 and 0. And it means the interval will kind of be shifted to the right. So in case B, the interval of f of x we're talking about is shaped like this. As you can see, now the minimum value is when we have f of b, which is equal to 2a. And we also know that right now b is equal to 13 over 4. So it's saying that f of 13 over 4 is equal to 2a. And we could directly substitute 13 over 4 into our function. That would be equal to negative 1/2 times 13 over 4 squared plus 13 over 2 is equal to 2a. This would leave us with a is equal to 39 over 64. However, this contradicts with our original statement that a has to be less than 0. In this case, 39 over 64 contradicts that, which means that case B is not a valid road to go in order to find the solution. Now, going back to case A, let's further solve for A. When we substitute a into our function, we get negative a squared over 2 plus 13 over 2 is equal to 2a. So we have negative a squared plus 13 is equal to 4a. Now we can use the quadratic formula. a is equal to negative 4 plus or minus 4 squared, which is 16, minus 4 times 1 times negative 13 over 2, which is equal to negative 4 plus or minus 68 over 2. This is equal to negative 2 plus or minus 2 times square root of 17. Remember, we said that a must be less than negative 13. So we can only take one of these solutions. A must be equal to negative 2 minus 2 times the square root of 17. And this is a valid value for a. So this was case 2. Now we still have case 3. This is when a is less than b, but both a and b are greater or equal to 0. It means now, on our parabola, this is the middle line of our parabola, the interval we're talking about is from here and onwards to the right. So here, the function is always decreasing. The maximum value occurs when we have f of a, and that can also be represented as 2b. And the minimum value is when we have f of b, and that can be represented as 2a. So now let's substitute a into our function. And we can also substitute b into our function as well. Now we can further simplify to solve this systems of equations. We are left with a squared minus 4a plus 3 is equal to 0, and b squared minus 4b plus 3 is equal to 0. As you can see, these two equations look very similar. They are actually symmetrical. For this quadratic, there are two roots. One is 1, and the other root is 3. So how do we assign these values to a and b? Well, remember, earlier we said that a is less than b. So we can say that a is the one that's equal to 1, and b is the one that's equal to 3. So in case 3, we also found a pair of solutions for a and b. It's 1 and 3. So there are two possible solutions for the interval a comma b. The first is 1 comma 3, and the second is what we got from case 2a, which was negative 2 minus 2 times square root of 17, comma 13 over 4. I hope you learned something from this video, and I'll see you in the next one.